So hello everyone, in this audio class we will discuss the 20 most important questions from the chapter Distribution of Oceans and Continents. So chapter 4 NCERT, these questions will be very much important for your upcoming KVS and NVS interview Geography PGT. So let's get started with the question number 1. Why is the distribution of continents and oceans considered uneven on the Earth's surface? So the distribution of continents and oceans is uneven because about 71% of Earth's surface is covered by water and only 29% by land. Most of the land area is concentrated in the northern hemisphere, while the southern hemisphere contains a larger proportion of oceans. This unequal arrangement influences climate, ocean circulation and human settlement patterns. Next question, how does the distribution of continents and oceans influence global climate patterns? So, oceans absorb and store a large amount of solar heat and release it slowly, while land heats and cools rapidly. Therefore, areas near oceans experience moderate climates, whereas inland areas often experience extreme temperatures. Ocean currents also transfer heats from low latitudes to high latitudes and help regulate global climate. Next question, why is Asia regarded as the most significant continent in terms of physical and human geography? So, Asia is the largest continent and contains the world's highest mountain, that is Mount Everest, largest plateau, that is Tibetan Plateau, and several major river systems. It also supports the largest population in the world. Due to its size, diverse physical features and large population, Asia occupies a unique position in both physical and human geography. Next question, what is continental drift theory and what problem was Alfred Wegener trying to explain? So, continental drift theory was proposed by Alfred Wegener in 1912. According to this theory, all continents were once joined together and in a single supercontinent called Pangaea and later drifted apart. Wegener tried to explain the remarkable similarity of coastlines, rocks, fossils and geological structures found on different continents. Next question, why was Wegener's continental drift theory initially rejected by many geologists? So, although Wegener presented strong evidence, he could not explain the force responsible for moving the continents. At the same time, concepts such as seafloor spreading and plate tectonics were unknown. Therefore, many geologists rejected the theory because there was no convincing mechanism for continental movement. Next question, what evidences did Wegener use to support the idea that continents were once joined together? So, Wegener used several evidences: jigsaw feet of continents, similar rock formations across oceans, tillite deposits, placer deposits, fossil evidences. These evidences suggested that continents were once part of a single landmass and later drifted apart. Next question, explain the significance of jigsaw feet evidence in continental drift theory. So, the eastern coastlines of South America closely matches the western coastlines of Africa. This remarkable feat suggests that these continents were once joined together. Wegener considered this one of the strongest evidences supporting continental drift. Next question, how do fossil evidences support the theory of continental drift? So, identical fossils of plant and animals have been found on continents. They are now widely separated by oceans. For example, fossils of lemur-like organisms are found in India, Madagascar and Africa. This indicates that these continents were once connected. Next question, why is the occurrence of similar rock formations on opposite sides of the Atlantic Ocean important? So, rock belts of the same age and composition occur on both sides of Atlantic Ocean. For example, ancient rocks along the coast of Brazil match rocks found in the Western Africa. This similarity suggests that the continents were once united. Next question, what is tillite and how does it support the idea of continental drift? So, tillite is a sedimentary rock formed from glacial deposits. Similar tillite deposits are found in India, Africa, Australia, Antarctica and Madagascar. This indicates that these continents once experienced the same glacial conditions and were connected in the past. Next question, what was Pangaea and how did it eventually break apart? So, Pangaea was a supercontinent that included all present day continents. Over geological time, tectonic forces caused Pangaea to split into two large landmasses, Laurasia in the north and Gondwanaland in the south. These landmasses later fragmented into present continents. Next question, differentiate between Laurasia and Gondwanaland. So, Laurasia in the northern part of the Pangaea included North America, Europe and Asia, and Gondwanaland, southern part of Pangaea included South America, Africa, India, Australia and Antarctica. Together they formed the original supercontinent Pangaea. Next question, how did plate tectonic theory improve upon Wegener's continental drift theory? So, plate tectonic theory provided the mechanism that Wegener could not explain. It states that the Earth's lithosphere is divided into plates that move over the semi-molten asthenosphere. This theory successfully explains continental movement, earthquakes, volcanoes and mountain building. Next question, what are tectonic plates and why do they move? So, tectonic plates are large, rigid sections of the Earth's lithosphere. They move because of convection currents generated by heat from the Earth's interior. These movements cause continental drift, seafloor spreading, earthquake and volcanic activities. Next question, distinguish between major plates and minor plates with suitable examples. So, major plates that are very large tectonic plates, for example Pacific plate, Eurasian plate, African plate, Antarctic plate, and minor plates are smaller tectonic plates, small Arabian plate, Nazca plate, Caribbean plate, Cocos plate, etc. So, major plates cover most of the Earth's surface whereas minor plates occupy smaller areas. Next question, why are divergent plate boundaries called constructive plate margins? So, divergent boundaries are called constructive plate margins because new crust is formed there. As plates move apart, magma rises from below, cools and solidifies, creating new oceanic crust. Therefore, the Earth's surface is continuously being constructed at these margins. So, next question, explain the process of seafloor spreading and its significance in modern geology. So, the seafloor spreading occurs when tectonic plates move apart at mid-oceanic ridges. Magma rises from the mantle, cools and forms new oceanic crust. This process continuously creates new seafloor and supports the theory of plate tectonics. It is one of the most important discoveries in modern geology. Next question, how does the seafloor spreading provide evidence of plate movement? So, seafloor spreading shows that the new oceanic crust forms in mid-oceanic ridges and moves away in opposite directions. The age of rocks increases with distance from the ridge. This proves that tectonic plates are continuously moving and that ocean basins are continuously expanding. Next question, why are the Himalayan mountains considered a classic example of continent-continent convergence? So Himalayas were formed when the Indian plate collided with the Eurasian plate. Since both are continental plates, neither plate was subducted. Instead, the crust folded and uplifted, creating the Himalayan mountain system. It is one of the best examples of continent-continent convergence. Next question, and this is the last question for today. How are earthquakes, volcanoes and mountain building related to plate tectonics? So earthquakes, volcanoes and mountain ranges occur along plate boundaries. When plate collide, separates or slide past each other, stress is generated in the earth crust. This stress causes earthquakes, this stress causes earthquake. So magma movement creates volcanoes, while plate collision result in mountain building. Thus plate tectonics provides a unified explanation for this geological phenomena. So thanks for listening. Keep listening for further audio classes. Thank you.